And for this one, we are going to need one of the advanced strategies. If we think back to the very first strategy we learned was change things to sine theta and cos theta. And then once you changed it to sine theta and cos theta, part 2 of that strategy was, can we get a single fraction on both sides? So that is a strategy that will get you lots of points, but we get to this proof and you're like, oh, it's already in cos and sine. So I can't do the strategy of changing anything to sine and cos because it is already in sine and cos. So then you go, okay, what about the second strategy? What if I get a single fraction on both sides? Well, the left-hand side is already a single fraction, and the right-hand side is already a single fraction. And this will sometimes happen in a question, and you will be stuck. You will have done the main strategy of get a fraction on both sides, and you've changed everything to sine and cos, and things don't match up. So there are 2 main strategies when you get stuck. Strategy number 1 is factoring, and strategy number 2 is a new strategy, and I call it build the other side. Technically, the build the other side strategy uses something called the conjugate, but nobody remembers what the conjugate is. It's a hard word to remember. You don't really know what it means, so then you don't remember the strategy. So I changed the strategy name to build the other side because it's easy to remember, and it also tells you a little bit of what to do. So this is going to be a question we are going to use the build the other side strategy because we've got a single fraction on both sides and we are stuck. What the build the other side strategy does is it says, if the 2 sides aren't equal, why don't you make something equal? Like, why don't you make the denominators or the numerators the same? What would happen then? Maybe a hint will appear. So what that means in this question is saying, well, on the right-hand side, I have 1 plus cos theta as a denominator. On the left-hand side, I have sine theta as a denominator. So if I wanted the denominators the same, I'm never allowed, because the line says you can't move from one side to the other, but you're always allowed to multiply by 1. So on this side, I'm going to multiply the top and bottom by sine theta. And on this side, I'm going to multiply the top and bottom by 1 plus cos theta. What that will do is that on both sides, and I'm not even going to multiply out the bottom, I'm going to leave it factored. On both sides, I'll have the same denominator. On the right-hand side, my denominator will be sine times sine, which is sine squared theta. And on the left-hand side, 1 plus cos times 1 minus cos. This unit uses differences of squares a lot. So do you recognize that 1 plus cos times 1 minus cos is the factored form of a difference of squares? Then you can multiply it out really quickly and get 1 minus cos squared theta. So the build the other side strategy says, let's make something the same. If nothing's working and I'm stuck, what would it look like to make my denominators the same? And you can do that by same way you get a common denominator for adding and subtracting fractions. And now that my denominators are the same, now I look at my new question and say, is there something that I could do? Because this side has sine squared in my numerator, this side has 1 minus cos squared in my numerator. And you're like, yes, that is just one mental math manipulation of our big idea, right? Sine squared plus cos squared equals 1. Can you see that if you move the cos squared theta to the right, you would get 1 minus cos squared? So I can, without losing a mark, immediately change that to sine squared theta. And the proof which originally looked like it was impossible, becomes doable. So the build the other side strategy, only use it if you're stuck, can't see what to do, right? Then you can build the other side. Sometimes factoring will be faster, okay? So when you're stuck, you should always look if there's something you could factor first. But if not, you have the build the other side strategy. One of the hints for a build the other side strategy is if you look at the original equation and you have conjugates. This is what the word conjugate means in math. Conjugate in math is the same binomial, just one is positive, one is negative. Like in a difference of squares is multiplying two conjugates together. If you have conjugates on the diagonal and something squared on the other diagonal, and the things that are involved are one of your Pythagorean identities. So in this one we have sine squared plus cos squared equals 1. What we have involved here is sine squared and cos squared. Or you have tan and secant, or cotangent and cosecant. That's a hint that the build the other side strategy might be the fastest method. All right, let's look at the second proof. So a quick look at the second proof. We don't have single fractions. We can change things to sine and cos. We can get a single fraction. What I would like you to do is, after writing out the question and drawing the line, is I would like you to change the right-hand side to sine squared and write it as a single fraction. And the reason I want you to try it first is there is a common mistake that happens on the right-hand side. And I want you to see what you think you should do, because what you think you should do now will be the same thing you will do on a test. Whether I show you the right way or not, I guarantee, like, it's human nature. We sometimes have things in our head. We will go to what our gut tells us to do on a test. So on the right-hand side, I want you to change the cosecant squared to sine squared and simplify that side. And if you make the common mistake and you see it now, then you'd have less of a chance later of making it. So here's the debate, and here are the two answers that come up. One of them is right and one of them is wrong. Some people will write 1 over 2 sine squared theta, and some people will write 2 over sine squared theta. So we have to decide which of those two is correct and which one is wrong, okay? So if I take this step by step, okay, cosecant is 1 over sine squared. And if you take it step by step, it becomes more obvious which one is the right answer. If you do it all in one step, you might be tempted to do the wrong thing. This 2 out in front is really a 2 over 1. So if we think about how do we multiply fractions, we multiply the tops, 2 times 1 is 2, we multiply the bottoms, and we would get 2 over sine squared. But you will be tempted to do the wrong one because you're like, oh, I'm flipping it 1 over, I'll just put the 2 on the bottom as well, okay? So sometimes if we take the extra step and do it one part at a time, it becomes more obvious why that 2 does not move to your denominator and stays as your numerator. Now, on the other side, we have 2 fractions that are added. And if we look at the denominators, if I put brackets around them, they are not the same. So how do I add fractions? I need a common denominator. The first one, you're going to have to multiply by 1 plus cos theta. And if you multiply the bottom by 1 plus cos theta, you have to multiply the top by 1 plus cos theta. And the second one needs to be multiplied by 1 minus cos theta. So if you multiply the bottom by 1 minus cos theta, you need to multiply the top by 1 minus cos theta. Then I would have a common denominator. And that common denominator is two conjugates. And when you multiply two conjugates together, you get a difference of squares. So the bottom will become 1 minus cos squared theta. The top, I'm adding them together. I'll have 1 plus cos theta plus 1 minus cos theta. I can write that out. 1 plus cos theta plus 1 minus cos theta. I hope you can see that the cos thetas are like terms, and they would go to 0. And you would end up with 1 plus 1, which is 2. And on the bottom, you have 1 minus cos squared theta. On the other side, you have sine squared theta. Well, that's just one mental math manipulation of our big idea. So you are able to, without showing any more work, just change the 1 minus cos squared theta to sine squared theta. And we are done. Okay, so circle question 12A. And then I would like you to turn to page 620. And we're going to write down all the strategies we've had, and we're going to sort of code them a little bit. Okay? Combine fractions by getting a common denominator. I have talked about getting things as a single fraction. So we can write that that is there. This is usually the number one strategy. These two. Not always the best strategy, but if you haven't tried that, if you're stuck and you haven't tried the number one strategy, then I'll say, well, why haven't you tried the number one strategy yet? And see where it takes you. You can get a lot of marks by using the number one strategy. Thank you. Okay? I'm going to put an S beside these three. The multiply by 1 conjugate is really another name for the build the other side strategy. But if you get stuck, you've tried the number one strategy and you're stuck. You've tried other strategies and you're stuck, then you're going to need to either factor or build the other side. Okay? And on a test, if you get stuck on a proof, it's not cheating if I say, what did I tell you when you get stuck? And hopefully that triggers for you, oh yeah, I should check if I should factor or I should check if I can build the other side. I'm not able to tell you on a quiz or a test, you need to factor or you need to build the other side. But I can tell you, oh, you're stuck? What did I tell you you should do when you're stuck? And hopefully then you remember those strategies. And then the number one strategy is not always the best strategy, okay? It's the number one strategy because you use it the most and it's a very good strategy. But sometimes if you look at what your goal is, if you look at the other side and see what's available, you might realize you can use a Pythagorean identity. Like one of the sine squared plus cos squared equals 1, or tan squared theta plus 1 equals secant squared, or cotangent squared theta plus 1 equals cosecant squared theta. They can often make your proof faster. So don't just jump into a proof right away without pre-thinking what might be a good strategy. If you pre-think and have no idea, go to the number one strategy and see what happens.